We're just checking everything's
We're
working.
just doing the tech check, making sure everything's sweet, making sure stuff's coming through.
Everything's sweet.
Oh,
That's good.
I can hear myself in someone's.
That's
That's probably me coming through on my other one. Who knows? We'll find out.
probably me coming
Make sure we get that nice feedback for us as we're presenting.
Make sure we get that nice feedback for us as we're presenting. Make sure we get that nice feedback for us as we're presenting. That's what I was saying about the Twitch.
I muted my Twitch. Anything else that I need to mute?
No, we're good. I think we're good.
All right, 7 o'clock. Shall we start?
On the dot. Let's kick it off.
Goodness.
All right.
Well,
so,
James, over to you. Go, James.
I did last month.
No, you got it. You got it.
No,
I'm a gentleman. It's after you.
All right. Welcome to Alt.net, and now over to Richard.
Oh. Best introduction ever. So hi everyone, welcome to the stream as always. Yet another month of the virtual Alt.net. So this month we've got two awesome presenters. We've got David, as you can see down the bottom. Oh wait, that camera.
Yeah.
Over here. Yes, something we're great at this stuff. Who knows camera tricks? It's terrible. And continuing our Brady Bunch moment up here. Andrew's over here, the nose ratio himself. So we've got, in terms of content, we've got source generators, which is a really cool new feature in C#, which we've mentioned briefly a few months ago, a few meetups back. So David's going to give us a run through of that. And then Andrew's going to be talking some coroutines and IAsyncEnumerable goodness coming out of C# as well. So that's pretty much it. Oh, and most importantly, I've just had handed to me the homemade custard scroll.
Wow.
That is awesome, and it's still warm, and I am just going to have to go on mute. Otherwise, I'm going to dribble a little bit because this is just, I mean, check that sucker out.
Yeah, so we all have the competition, which you can have some of, unlike Richard's scroll. So we've got 2 JetBrain licenses to your way, so listen closely because there'll be 2 questions at the end, 1 for each of the licenses. So 1 from each of the talks, as usual, and they'll give you access to any of the JetBrains products.
Yep.
All right.
What he said.
Exactly.
Okay.
Kind of weird.
Jimmy
Right.
P, how you doing? Welcome. MQIza2. I have no idea how to say that. Probably something cool. But anyway, welcome to everyone. Say hi in the Twitch channel. We'll answer questions as we go, as always. We like Alt.net to be interactive, so if you've got anything coming up as it's going along in terms of content, or can this meetup give away cake? Maybe. Yeah, as I was saying, as things come through, we'll pop the questions up in down the bottom of the screen. Ask them for you, make sure it's clarified. So we want this to be valuable for you, so ask away. We love it.
Yeah. One of us will voice your question. All right.
I got it.
Very good. So we have David first from Microsoft on the source generation. All right. You good to go, David? I'll bring your screen up.
Yep, all good.
Roll, baby.
Hang on 1 second. Not like that. Sorry, guys. All like that.
Oh, James has made himself the center of attention now.
Yeah, I just wanted the chance to be center screen. That's what we actually want.
That's what we're going for. We're good.
All right. Thank you. Hello, everybody. Welcome. Yes, please do ask questions. Interrupt such as you can on Twitch chat. It's not that wonderful, but it'll be good. Yes, hello, I'm Dave. I work for Microsoft. I work on Roslyn stuff, so very, very related to source generators. So let's talk about source generators. Source generators are something that is, if you haven't used them or heard of them, you're probably going to like them because all developers like them because they are about automation and they're about taking stuff that you would normally do and automating it, so saving you time. So like my first exposure to source generators was with an ORM, like entity framework like thing, although this was many, many years ago, so it wasn't entity framework. But if you think about, if you've used entity framework, if you create one of those graphs in Visual Studio.
Sorry, I just need to ask, was it LLBL Gen?
No, this was, what was it called? It started with CSLA, I think was what it started with.
Oh, yes.
We customized it out the wazoo and essentially.
And regretted it incredibly.
Yeah, it's all just mine. I just wrote it all. Yeah.
All right, I'll person
yeah.
moment over. Carry on.
No, it's fine. Interruption's good. But yeah, so if you have used Entity Framework though, if you've ever done the visual, what is it, DGML, where you drag the database tables onto the screen, you press save, it generates a whole bunch of code. That's exactly what we're talking about. Stuff that is repetitive that you don't want to handwrite, so get something else to run. So source generators. So there's plenty of ways to do source generation right now. So CSLA, like I mentioned, that was using something called CodeSmith. But then we rewrote that to use T4 files, which are templates that's built into Visual Studio. You can write custom MS build tasks. You can sort of do things after the build with FODI or FODI, I don't know how you pronounce it, post sharp, that sort of thing. So you might have heard of some of those. What's new in C# 9 around source generators is really there's two sort of, well, one selling point and one other fact that some people like, and that is this is the first sort of official C# source generator done by the compiler team at Microsoft. So it's a really blessed solution. People have wanted source generators for ages. There's lots of reasons why they haven't been around yet, which I can talk about. But yeah, so this is the first sort of official one. The really cool part is that because it's done by the compiler, it has a unique selling point, which is access to the compiler internals, which we will talk about now. So on the screen is a very high level diagram of what happens when you press build in Visual Studio or on the command line. So basically your CS files go into the compiler and then a project DLL is produced. Great. So let's talk about what happens inside the black box or the pink box, as the case may be. So the compiler has essentially 3 phases. There's kind of 5. Anyway, it's very high level. So the first thing that happens is your C# files are parsed. And from there, that produces what's called a syntax tree or an abstract syntax tree. So this is information about your source code. It's richer than your code, but it's not super rich. It doesn't have type information. Like if you have the word string, then the syntax tree says you have the word string. If you have the word string with a lowercase s, then the syntax tree knows that's a string type. So it's got a little bit, but not much. Anyway, your syntax tree then moves into the compile phase. And so it becomes a compilation. The compilation has all of the rich information you would expect. So types and references and all that sort of stuff. And then normally what would happen is your compilation would go and be emitted out into your DLL. With source generators in the mix, what happens in C# 9 is the syntax tree and the compilation is sent across to your source generator where it generates source, because that's what it's called. And the source is just a string. So it makes a string that sort of, if you like, goes for a ride alongside your C# files. So that string is then sent back through the parse phase, becomes a syntax tree, and then becomes a compilation. It gets merged with the other compilations that you already had from your source file. And now we go through the emit phase. So having access to those syntax trees in that compilation really gives this a unique, it gives it a lot of power. Now, it's not ultimate power. Something like FODI or post sharp that runs after the build has similar levels, if not more power, but they also have to work on IL. So this at least gets to work on a little bit more of a sort of an understandable C# ish level. So that's how they, well, God, hang on. What's this? Hang on, sorry. Oh, sorry. I think Twitch stuffed up there. So let's talk.
Shameless plug.
Yeah. So, okay. Some frequently asked questions that are potentially frequently, but not many people ask them yet because source generators are kind of new. So the first question most people ask is, does the source you generate exist on disk? And the answer is no for now, but in future there is plans that there'll be some kind of flag in MS build in your project file. You can say, yes, output me these. Can you have multiple? Yes, you can have as many source generators as you like, but the key thing is, based on the design as run through in that high-level PowerPoint diagram, all of your source code is compiled first, and then it gets sent to your source generators. Those source generators, if there were more than them, the order they run in is undetermined. So you can't rely on the fact that there's another source generator. So you can have multiple, but you can't kind of chain them together, if that makes sense. Is there a better way than producing strings? There is, but also you're not going to be allowed to do it. So what ends up happening, and we'll see this in a minute, when you're writing these source generators, right? You're deep in this C# compiler world. You're in the Roslyn API, and you want to generate, syntax, because that's what you're looking at. You don't want to have to bother with strings, and it's really tempting to just ask for higher level API. Say, hey, I want to give you a class or a method. I don't want to have to give you a string. But it turns out that the C# compiler, it's really good at parsing strings into syntax, and it's very quick and it's pretty low cost. But if you give the compiler some arbitrary syntax that you've crafted manually, it's really easy to crash it, and there's lots of bugs. And essentially, that part there's no need for that to be public. So no, it's always going to be strings. What you sort of sometimes do is you generate the syntax in this higher level concepts or whatever, and then you call toString at the end, which I'll show you that too. Can they change code? No. This is the biggest sort of, it's a gotcha to people who don't know about it and they assume that you can. But it's also the biggest reason why we finally have source generators, because it makes the problem that much easier. Essentially, your compilation from your source generator gets put next to the compilation from the real source files. And, I said they were merged together. There's not really much merging because they can't possibly occupy the same space, if that makes sense. So they can only add on to code, but there is things you can still do. And the IDE experience, which is the team I work on, it's definitely going to get better. It's going to improve. So things that will be allowed soon, things like go to definition, debugging, that sort of thing. You'll be able to see the code that gets generated through those mechanisms, even if they don't exist on disk. But right now, it's a little rough, which we'll also get to. So what are we doing? Okay. I don't know how long we're going to go for. All right, I'll just dig in quickly to some details, and then I'll just go demos because they're more fun. So some other things the source generators can access. They can access additional files. So if you define an additional file in your project, the source generator will be given that file contents. So that means you could write something like a strongly typed wrapper for a settings or a CSV file or a JSON file, right? If you've got a Swagger definition, you can write a source generator that reads in that Swagger definition and generates you a client or something. My friend Scott, there's a link down the bottom. My friend Scott wrote a transpiler from a language called the Brain, F-U-C-K, I won't swear, into C# by using a source generator. So you give it a file, a BF file, and it produces C#. It's amazing. You can raise errors from source generators. So your errors, if you call report diagnostic, you can create a warning, an error, a message. You give it whatever message you want. It comes up in the build. It comes up in the output window. It comes up in the error list. So you really are part of the compilation. If you were consuming someone else's source generator, you might not even know where the messages come from. But it is nice to give them a code that sort of tells people. It's tempting to use this ability to write like validators for code, but try not to do that because we already have analyzers that do that. So, they're a bit better at it. Partial methods. Okay, so the other, excuse me, this is not specific to source generators, but so I said they couldn't change code. So something else that's happening in C#9 to help with people writing source generators is partial methods got a lot of love, let's say. So previously, a partial method in C# had to be, it couldn't return anything, it couldn't have out parameters, and it couldn't be visible outside the class. In fact, it couldn't have any visibility at all. Like even the private keyword was banned. And conversely, they didn't have to exist. So a partial method was used as a way to say, I might want to put some code here, but I might not. Let's see what happens. Post C#9, you can now have returns and output parameters, and you can have visibility, public or protected or private or whatever. But the flip side is, if you have any one of those things, you have to define the full method somewhere. So what these are used for is you put in your code partial method blah, and then you generate the implementation of that method. So you kind of think of it sort of like having header files in C, which is probably not an analogy that you want to think about, but essentially you sort of define these points where the source generator can sort of plug in the code. It's still not completely like transparent because the class has to be marked as partial, and so there's some gotchas, but it is possible to affect things, and I can show you that as well. Generating syntax. So generating syntax, I mean, you probably can't even see it on the left. It's tiny font. I put it there to illustrate how annoying it is. To generate the syntax that's on the right there, that little program, that's the sort of strongly typed way in Roslyn. It's really quite annoying. So it will be tempting to do it, but trust me, it's annoying. There is that website there, which I'll show you in a sec, which makes it easier, or at least gives you all that guff on the left for what's on the right. But yeah, there's lots of traps with it. So if you do play around, the biggest trap is when you generate syntax that's strongly typed, it's very strict, let's say. It's very exact. So in this bunch of code on the left here, down the bottom here is a method call that says normalize white space. If I get rid of that call, my code on the right looks like that. Now that is not valid C#, right? And so this is part of the reason why source generators provide strings. It's trivially easy to provide a syntax tree that works as a syntax tree, but doesn't work when it's code. So be careful with how far you go with syntax, I would say. Reading syntax. So this is one of the main things you can do with source generators. You don't have to read the code, but obviously one of the unique benefits of being part of the compiler pipeline is you get to read the code that's in the project. So there's a bunch of tools to talk about to help you, which I've just put up there quickly. The syntax visualizer, which is the thing on the right, is built into VS if you have the compiler platform optional workload ticked. And that just lets you look at any C# file and see what the syntax is, which helps you because what you'll be doing is trying to write code that navigates this tree. So it's good to see an example. SharpLab is a web-based tool that has the same sort of view. I'll show you that in a sec. The main way that I do it is trial and error. So use the debugger, grab a syntax node somewhere, have a look at it in the watch window and just kind of click through and see everything. It's very, very detailed. And so trying to understand all of the possibilities, I mean, you basically have to read the C# spec, and I haven't done that and I'm not going to. So the other part that you get access to is the symbols. And this is the more powerful of the two because this is the meaning of the code. So this is all of the types, right? This is the word string actually means system.string from mscorelib.dll. And so the key things you might want to know there are global namespace. That property gives you every single thing that your project could possibly need, well, to compile, although it's already been compiled. That's how we got it. But so that is every bit of every method, every property, every field, every type, every assembly from every reference and your project. Like that is the entire world, essentially. If it's not in that global namespace, it doesn't exist. So if you want to look for anything, you can look through that. And then what you do is you call getType by metadata name, which basically says, give me a fully qualified type name, and that'll give you the strongly typed symbol for it. Then you can go looking for that. The semantic model is what describes the code. We'll see all these things in a sec. The syntax visualizer has support for symbols. You can right click on nodes and go show symbols, and I've never got it to work or show me anything useful, but there you go. So again, trial and error. If you have a symbol, open up in the debug in the watch window and just start exploring. It's the best way. To define a source generator, and I think this is my last slide before I have a demo. God, I've only got 10 minutes left. So source generators use the analyzer infrastructure. So you have an analyzer item you add to MS Build. That's if it comes from NuGet or something, you would use that, or that would be part of the NuGet package. If you want to do it from a project reference, that's how you do it. Essentially, you say, hey, reference this project. Don't actually reference the DLL. And instead of being a reference, it's actually an analyzer. You just trick MS Build into doing it. And then the analyzer itself is really easy. You reference the right packages. So analyzers package, the workspaces package. And then you just tag your class with a generator attribute and you implement iSource generator. And then you'll get given, or you implement these two methods, you get given a context, and that has everything you want on it. That has the syntax trees, it has the compilations, it has additional files, etc. And I think, debugging. So debugging is the hardest part at the moment. Hopefully it'll get better. Debugger.launch, putting that in your source generator is a great idea. That'll pop up and say, hey, how do you want to debug this? Just pick Visual Studio and step in the code. There is a thing called the generator driver that you can use. If you look at that source generator template I have a reference to, that's got an example of how you would use that from either a console app that you just run and it outputs the source, or unit tests. And then the other thing is sourcegen.dev, which I will show you in a second, which I wrote because it was frustrating me. And I think that's my last slide, so I will whip over to my browser. So Roslyn Quota. So this is the first little tool, and this is cool if you want to write code out and you don't want to do it as a string for whatever reason. But you can see this is the code that we produce, right? And in fact, if I click on preserve whitespace and keep redundant API calls, it gets even worse. And it just keeps going and going and going and going. And this is the thing where, see this whitespace here, right? Like this is the trap where if you don't output whitespace, you won't get any when you call toString. So it's a useful tool, and it's good to tell you the sorts of things you might want, but I'd be wary of it. SharpLab is fantastic though. SharpLab, you type in some code, and then, well, if you click syntax tree in the results, it just shows you the syntax tree. And as you can see, as I'm mousing over these things, they highlight on the left. Same thing in reverse. If I, right, here's my one, right? And I can see, oh, this is, so you go through and like, I want to find return statements. Okay, then what's the thing after return statements? Oh, it's an expression. Okay, so look in the expression property, right? So that's the sort of thing you get exploring. And now for the real fun. So what are we actually doing with them? Let's have a look. So this is a source generator I wrote. Well, this little tool, let me explain what this tool is first. In this box here, we have our program code. This is essentially my project that I'm referencing the source generator. I've added a reference to the source generator to this project, if you like. This is the code for the source generator itself. This is going to generate some code. This is the code that we generate. And then this is the code. This is the output of the program once you munge all these things together. So why a source generator is cool? Okay. What this source generator does is it's a basic DI system. So it's got a service locator. Right? I have here a bunch of interfaces that don't do much. So I'm going to say, hello, source generator, or hello, service locator. I want an IFOO. The source generator then looks at the code and it says, all right, someone wants an IFOO. I will go find how to do that. And it can see it's found the foo type and it's constructed it. And it's storing it in a field, and then it's giving it back to you when you call get service. Now, the cool thing about source generators, I think, is when you start to get used to thinking within the compiler, you get to start to do some cool things, right? If you were writing a service locator, this is a dumb one, because all this ever does is gives you a one thing, which is an IFOO, right? Why is this generic? It only ever gives me an IFOO. The reason is this source generator knows that this code only ever asks for an IFOO, so it doesn't have to put in checks. If I ask for an iBar as well, now my source generator says, well, now I better have an if statement, right? And so you start to get used to thinking like, instead of writing a library where you have to react to any possibility, you get to write code that knows exactly how it's being used, right? And so in this case, now we have an if statement to check if it's an IFOO. Otherwise, we're going to give you back a bar. Again, it doesn't need an if statement for iBar because it knows that there's no other possibilities. If you didn't fall into this if statement, then you must want an iBar. And it's generating lazies because otherwise that would be inefficient. And you can do things like, if I turn this off, this is now generating non-lazy fields. So they immediately get rendered. I can do things like put in an attribute here that says this is a transient reference. Now it'll change how it generates. It gets rid of the field, it puts in this thing. So you get to generate exactly the code you need. There's no, like in terms of DI, right? This would all be a bunch of reflection normally to work out how to do these things. And then there'd be probably a bunch of different code paths you'd have to support for, you know, at runtime, they might be able to say if they want lazies or not, right? Well, let's say there was a Boolean property here that said whether I want lazies. That's still not runtime because the source generator gets to look at the code. Now, the other cool thing is, of course, errors. If I ask for a service where there is no implementation, I get a build error. And so instead of a runtime exception because my DI container couldn't be created, I've got a build error that says, hey, this app was not going to work. I don't know when it wasn't going to work, but at some point, this app was going to fail. There you go. All right. So there's some of the cool things you can do with source generators. Just to quickly show, I've got 5 minutes. I'll just quickly show the partial class bit as well. So this is a example generator. This is up on GitHub on the official samples thing linked from the blog post. But so this has partial classes. And so this is an example of extending the class. So here we've defined a partial class called example view model, and we've just said, here are some fields, and we've put on an attribute. What this source generator does is it goes and finds that attribute. And if we scroll down here, yeah, this is put in another partial class. So this is the other half of this class that we wrote. So we hand wrote one, we generate the other half. And what this does is it implements notify property changed. So this creates the properties automatically from those fields, and then it calls the property change. And then you can see here, this count property is returning the amount field. Again, that comes from this attribute. But the cool thing is there's no reflection in this at all, right? This fact that you wanted to rewrite it was discovered at runtime. This attribute, excuse me, this attribute has no effect. It doesn't do anything. In fact, you can see it here. It just has a property. That's all it has. In fact, you could probably make it write only. Oh, except that the actual code pulls it out. But yeah, the source generator doesn't actually have to run the code. Actually, that's the other weird thing I was going to show you. If we go back to this example, I love this bit. So here's our generated output. We're getting a foo, right? If I remove the semicolon, this now fails to compile. But notice the source generator still generated a valid class. It still knows what you're doing, even though you've got it wrong. If I remove the close bracket, now we have some problems. Now our service locator says, hey, you haven't asked for anything, because the compiler doesn't know if this is a method call or if this is the start of a tuple or if this is a whatever. But once you give it enough syntax that you know what's going on, you can generate that code. And again, that's just another little quirk of thinking inside the compiler is you have to, well, you get to operate on code that may not be correct. And the benefit of that is you can start to see results from your source generator while you're typing out your code. This isn't like the old school thing where if it's part of MS Build, you write your code, you press build, you hope your source generator works. And if it doesn't, you try and work out what's going on. Because this is done by the compiler, it works, you know, in the command line, Visual Studio works everywhere. I think that's all I basically want to run through. If there's any questions or I don't know.
There are questions. Just a quick one while people are, or James is filtering out the questions. When you took that last parentheses off, and then we got the two, so line 17 and line 9,
Yes.
in terms of trying to diagnose where the problem is.
So yeah, so this is, well, the weird thing about source generators is that you get given the compilation even if it's not valid. And so in this example, like I'm using this window to show you all of the errors, but in Visual Studio, you can see this a little bit better. But yeah, so essentially, if you think about it, this here, this is where the problem starts. Because until this open bracket, this could be
the syntax is still
a
valid,
method could enter, right? So so this close bracket expected is probably saying, hey, what's going on here? Right, so the parser is trying to work out what you mean. But yeah, this no overload forget service, well, that's because this is still a method call. Like it knows enough to know that it's a method call. It just can't work out, like you've passed in this, which is weird. it's not normally a problem because it's kind of weird. The compilation created from this is not valid, but it still gets passed to this source generator. And then this one generates some more. Then they get merged together, and then it sort of rechecks. And if there's still problems, well, we'll tell you about them, but otherwise we won't. This is partly affected. Like if I can do the same trick over here. If I break the source generator, I'm going to get errors in the same place, but obviously in reality in VS, that's not.
So given the idea that we get past invalid syntax to play with, does that mean we can effectively, if we wanted, write our own keywords and extend the language using source generators?
No, because they still have to compile at the end. I mean, well, but I suppose to a certain limited extent, maybe you could, because if you can write a class that looks right such that the compiler will be happy with it at the end, then maybe, you could. But you could certainly use it to write sort of DSLs within C# a little bit. But I think you'd still be limited by, at the end of the day, these compilations have to work once they're combined together, and they still have to be C#.
Okay, so Aaron's dream of turning C# into JavaScript, probably not going to happen.
You can do it with additional files if you really want to. So you can have these files in your project. You just tell them not to compile, but the source generator still reads them, which is how that. Actually, I can go. Let me go back to that link. Where was it? Oh, where's the additional files? There it is. Go to this link, which is probably going to open the wrong browser because Oh.
Can we roll?
Yep, there we are. Wrong browser. Over there. You can't see it. And really, so what this does, so this has a file, which is a source file somewhere. And I mean, you won't be able to read it anyway because it's what it is. So this is a esoteric language, right? Called Brain FUCK. Oh, look, it's right there on the screen. And so this is source code, but the C# compiler doesn't know what this means. But that's okay, because in the project file, it says, don't bother about compiling this. But the source generator reads it in here. We read this additional file. And then in here, it's got a parser and it emits code and all the rest of it. So you can definitely do it that way. But doing one based on
that means
C# might be tricky.
Yeah, so something like the BDD tools, so SpecFlow, for example, where you take in a cucumber syntax, you can transpile that directly into
that's actually
potentially directly into something else.
Yeah, so the SpecFlow one's actually a really good example of why source generators would be good as well, because how SpecFlow actually works. I've gotten bugs raised against VS for how slow SpecFlow can be, because it has to compile all of your code in order to run the source generator, in order to output code that then gets run by the compiler. So it's a really inefficient process because it's trying to get at some of this type of guts. So if they can rewrite with source generators, then yeah, that'll be a much smoother process. And you can still raise errors and diagnostics. And if you say, hey, there's an error in this additional file, VS will happily show you that that's where the error is, even though it's not C#. It doesn't care. So yeah, those sort of things where code behind is generated are a really good use case for source generators. And I would expect to start to see some of those basic ones. So even like a Razor file, maybe they'll do some work with source generators and rewrite that. And that just means that instead of needing Visual Studio to compile or needing complicated MS build targets that work when Visual Studio is not installed, they can write one source generator. It's called by the compiler and it just always works. The other interesting thing though is whether they can get rid of reflection. So if you think about how a MVC controller works, at runtime, something looks at the controller, finds all the methods, finds all the attributes, etc. And so that is happening while your app is starting up. So if they can rewrite that in source generators, then that happens at compile time and your app startup is really quick.
I suppose there's also projects like Mediator as well that do something similar. Trying to hook everything up and yep.
Yep.
James, are there other questions?
How are
All right.
string literals with escape sequences? Well, I can show you. It's not that bad.
Yeah. Okay. It's your worst string literals.
Yeah. So if we go down here, so this is where right here I have the start of a file, and here I have a method, right? And it's not too bad. If you have to use like actual strings, that's a little bit annoying. But what you end up doing is creating, like, this is not the best code. You would end up creating stuff like this. So here's a method that says, hey, get me how to construct this type. And if you look in this method, which I think maybe, oh, there it is. So this then generates its own little bit of code. And so each little component does its own little work, and it's not that bad. The main sort of thing with source runners, if you're writing them, is think like a compiler. So the first thing you want to do is you want to go and find out all the information you need. And then as a separate step, you go and output the code. Don't try and output while you're sort of parsing or discovering, because that just gets hard. So what this one does is it builds up this list of services. Each service then has a list of services within it. But essentially, you go and build up all that information at the start, and then you output it as a second step, and it makes things a lot more easier. Thank you, Lord Teaspoon, for
the questions coming through. Just having a quick look at the list.
What do we got? Here we go. We've got one real-world example question.
Yeah, so real-world examples. Well, so there's a bunch of, I mean, things like this auto notify is one example where I know there exists Foddy weavers that do this. This is a really simple example, and maybe not everyone likes it because it uses fields. So whereas the Foddy weaver actually changes your property, source generators can't do that. But the sort of the number one real world thing, or the thing that I think is the first thing to think of, and why I started with dependency injection, is if you think about where you're using reflection, and unless you've got a plug-in ecosystem where you're downloading DLLs at runtime and so you don't know what might exist, if you've got any kind of reflection that operates over stuff that could be known at compile time, then you're basically moving that work from runtime into compile time. So you get your build server to do the work, and then your runtime is quicker. And it can also be way more efficient. If you think about, what this looks like when I ask for two fields, this outputs just enough code to work, to do exactly the job it needs to do. If you compare that to what a proper DI container would have to do, and the amount of code that it has to run and reflection, etc., this is a huge win. Some other things, though, that I think will eventually become source generators, things like routing in MVC. They redid that with endpoint routing, which builds up a tree and parses a graph and whatever. They can do all of that at compile time potentially. So a lot of things where you would gain efficiencies if you had a nicer data structure over some stuff. It's hard to do or annoying to write. You can just write a source generator that does that work.
Cool. We've got one last question on F#. Hang on, it just moved down. Hang on, here we go.
You kind of can equate it to F# type providers. The system is a bit different, and I think type providers are sort of by design a little bit more, in a sense, a little bit more robust. So things like, for example, your SQL, your classic SQL type provider that lets you write strongly typed queries, you wouldn't want to write a source generator that hits the database to download a schema. You wouldn't want to write a source generator that hits a web service, because the infrastructure of the compiler is not designed for that. So I was watching someone write a source generator that downloaded a JSON file from the internet to run their generation, and so they went to run .NET build on the command line, but of course forgot to start the server, so their build failed. The F# system it's designed with a very different use case, and so there's lots of differences, but I mean, you can fundamentally they're very similar, and I'm sure there are lots of type providers that could be written as source generators. But then the other thing to think of, this is a C# feature, a C# compiler feature. It's not a .NET feature. So F# doesn't get any of this. This is just in the Roslyn compiler. So type providers is essentially their equivalent, and they've just had it for longer, and yeah, has slightly
Well,
broader scope.
I think Aaron was trolling you. He sent a message afterwards
sure he
just saying
was
he
too.
wanted you to talk about F#. So yeah, that's how we roll.
Yeah, like water off a duck's back.
And then Scott's wanting to know if there's
Sounds
VB.NET
like-
support. More trolling.
Yes. All right, we better move along to Andrew's talk because we're halfway through the time or a little more. But we talked a bit at the beginning, so I mean, it's fair enough to have the full half an hour. So, put Andrew,
Subscribe to your Twitch channel. No.
well, you can post it in the comments so that people can do it even more easily.
We'll have to do that affiliation thing so we can pass people through when we're not online.
I'll have to start streaming then.
Yeah. Oh, well, do that too.
All right, let me switch us over to Andrew now. You ready, Andrew? You got one.
Yeah, I think I'm ready.
All right, here we are. This is Andrew's screen up now.
Hello, everyone. I'm Andrew, Ukrainian originally, so that's what my English flavor coming from. I'll be talking today about this coroutine things, which is a bit of confusing terminology. Pretty sure that everyone has dealt with that so far, because we all use IEnumerables or IEnumerator, which is a product. Like IEnumerable is at the factory, and IEnumerator is a product of the factory for our link stuff. But when it comes to coroutines, it's a way of execute things preemptively and cooperatively. Sorry, not preemptively, because threads are a good example of preemptive multitasking. Coroutines is something that executes cooperatively. So traditionally, people were using IEnumerable to generate data, but some other projects, like for example, Unity, they use it to generate video or like some transition effects just by spreading that enumerable and enumerator loop through multiple video frames in some specific timeline. It's very cool. Anywhere where you want to suspend something and then resume it upon some specific time intervals or events, or it could be, I say, some fancy stuff like IObservable, you can do that. It's easy to demonstrate. I have a little project here, and I posted the link in the channel for the repo. It's more like a blog post, which I'm going through. So let's try to recreate some simple stuff. Like let's start from synchronous coroutines, or what I call pull-based coroutines. They're not exactly synchronous because we suspend and we resume upon some specific events in the future, but they are synchronous in the way that we use how we pull those chunks between one yield return to another yield return. So we have like two routines here, coroutine A and coroutine B. They don't do much fancy stuff. They in real life they could be drawing some 3D shapes, or they could be doing some like background text spell check or syntax highlighting. Here in the simple example, we'll just be doing console output. So let's run it. Hopefully it will run. So I have my console, and this is a little GUI app for that. I start coroutine A and I start coroutine B, and they execute cooperatively. I can do some stuff. Meanwhile, everything is happening on the UI thread, it's cooperative. So one chunk from coroutine A between return yield to return yield gets executed upon specific timer event. Then the other one from coroutine B gets executed, and so on and on. So let's look at the code. We need something that actually drives that execution, and that something is called, like, I call it dispatcher. People call it dispatcher, or some other people call it coroutine driver. It's some piece of code that takes these two IEnumerable and combines them into sort of interleaved stream, synchronous stream of those chunks of code, if you will. And then it sets up a timer event, like say 50 milliseconds. And upon every single timer tick, it just goes to pull, move next, and on and on. And if there's any error, it will set exception on the task completion source. So it goes again. Actually have cancellation token here, so it goes forever until it's canceled. But if I don't want to do that, it will just go for 80 steps of this loop, interleaved with 80 steps of this loop. So it's all nice. That's how Unity draws shapes on specific timeline. But what if we wanted to use some asynchrony here? Like for example, what if I wanted to, if there's any input in like mouse move or keyboard character in the thread message queue, what if I wanted to process it fast without doing anything? Because otherwise it will be lagging in our application. I don't want any lagging. I want to process that thread input right away. We couldn't do that in a nice form with IEnumerable because it's synchronous. We couldn't do anything. We couldn't use async-await inside this coroutine until C#8. When C#8 was introduced like 2 years ago, there was a compiler support for IAsyncEnumerable. And what IAsyncEnumerable is exactly almost one-to-one mapping to IEnumerable, but the move next method that I showed here is asynchronous. So it, instead of returning the item, it returns the task, but item is a resolution for the task. Let's try to replicate what we've done with these two, Coroutine A and Coroutine B, IEnumerable based. Let's replicate this AsyncEnumerable. We wanna do something fancy, like it would be very simple just to replicate it one-to-one. So let's say we want to add a feature like this. So if, like I said, if there is any input pending on a thread, I don't want to go and I don't want to do any stuff. I don't want to execute anything on the AI thread until the input is consumed and we did something. So I have a helper class which I called input idle. It's idler. It's in the repo that I showed, that I posted the link to, which basically suspends execution and yields it to the message, to the event loop, to the up to the top to main, where we pick and process messages, and then continues when the queue is empty. So that's for coroutine A. We introduce some asynchrony here. For coroutine B, I want to do the same thing. So it's here, but also I want to slow down it a bit, like that. Let's run it. That's how it goes. And I think if I manage to do that, see, I started to move the window, and the queue is, the thread UI queue, the UI thread queue is full of mouse messages right now. So it's all suspended until I release my mouse button, and then it goes on and on and on. So that's all.
And
yep.
Question we got from the Twitch. So question, if I have multiple windows opening asynchronously, how will the notifications work in the background, and how will it affect the coroutines?
You can have as many windows as you want. This is just a single window application, but I could pop up many windows. The key is it's a single thread. It's all preemptive. So although it's asynchronous, all those chunks get posted back to the UI thread through synchronization context. So each of them is independent, but it's still the same UI thread. So if you look at the code, Like for example, this one. Or maybe I'll just show you the code for this. It's really simple. It's trivial. Well, maybe not as trivial because I'm using a new feature which is called value task, and I don't think I have time to stop on that. But it checks the message queue, and if the message queue of the thread is empty, it just returns continuation that will get us right after to this statement. So this will complete synchronously. It will not be suspended and postponed in the timeline. And the same is true for this coroutine. So they just chunk by chunk, they go like that. I say like that. Each one of them checks the queue and continues only if the queue is not empty. I try to answer the question, but I'm not sure if it makes any sense. Does it? It's a bit complicated. It's a bit mind twisted. Sometimes I feel like I don't myself understand everything that I'm talking about. So bear with me.
Like the rest of us.
But the thing is, all those events get serialized to the one single main UI thread. You don't have to worry about any kind of race conditions here. We need something that drives these two coroutines. So they don't execute by themselves. We need something that enumerates for them. And that like the dispatcher or like coroutine driver that I mentioned earlier for IEnumerable, we need something like that for asynchronous coroutines as well. So that's what that for each loop is here. It's again, we receive in this list, there's like one coroutine async method that accepts a bunch of IEnumerables, and then we do basic select statement, and for each of them we start a wait for each loop. And there is no magic in that wait for each loop. I actually replicated just for illustration purpose. All it does is gets enumerator, and there is little friendly while loop here that calls move next async on that enumerator and awaits it. And when it gets back the results, it just calls the action. So the body of that loop. That's why I call it, other people call it push-based approach, because results are getting pushed to that asynchronous loop instead of like we pull for them in IEnumerable case. Here, like I have freedom to do anything, because when I fetch the next step of each coroutine, I can put a delay. Like let's run it again. But pretty quick, I say. But what if I want to slow it down? I go here and I just put, say, I don't know, 1 second. And it's terribly slow now. But it's still one step at a time on the I thread. And we just introduced a delay between each step. I'm not sure if anyone's following so far. Does it make any sense? I don't know. Drop a question.
It's good. Yep.
It's good. Okay. It's all so far just all made up and contrived, so it doesn't make any sense in real life. But still, bear with me. What if I want this to these two coroutines, which so far they are independent one of another? What if I want them to synchronize somehow? That's where the fun begins. So I have here like asynchronous demo, asynchronous mutual coroutines, what I call it. What if I want coroutine A suspend its execution? Like they both have like 80 steps, like from 0 to 80 characters we draw on the console. What if I want coroutine A to be on hold until coroutine B progresses like through half of its workflow? Let me show you. So we run that again, and it's like that. So A is on pause until B is midway, and then A is catching up, and they continue together. That's something that is getting closer to the real life example. So I actually, there is a communication between them. They are becoming like producer-consumer to each other in a way. And for that, because I still need the external code that executes each of them, I need some kind of proxy that would be proxying those notifications, those like progress events from one coroutine to another. So I have here, oh, actually, let me show the picture. I have another diagram in my little repo. Let me see. Yeah, here. So that's coroutine A, and there's a proxy. And the proxy is just another IEnumerable that through a wait for each loop consumes items from coroutine A, stores them in some storage, and this storage, like asynchronous queue, they stay there until they are consumed by coroutine B. So that big, thick arrow is when the coroutine B wants something from coroutine A. It can't go directly to coroutine A because it's IEnumerable, another IEnumerable. We cannot pass IEnumerable for coroutine A into coroutine B and pass IEnumerable for coroutine B into coroutine A. They will just be like, it would be like asynchronous sort of deadlock. So I'm using that special proxy classes, A, proxy B. And internally, they use a new, very cool class of .NET runtime, which is called channel. And channel is like a pipe. You push items into one end of the pipe asynchronously. And this one is unbound channel. It's endless. It's limited only by amount of memory of your computer. So they stay there until there is someone who wants to consume them from another side. And looking at the code, it's actually very, very simple if you look at the code. It's another for each loop that creates a channel here, unbound channel. And I have all the links in that repo. So if you really want to learn more, you can just go there and read. Like, there's enough reading material there. But it goes asynchronously through that await for each loop, through coroutine A, consumes item from there. Again, like I showed you that this one, await for each. Whenever there is a new push notification, it puts it into that right end of the channel, and it stays there. The same thing happens for coroutine B. And now there is when I run them, let's go back to the actual code. So when I run them, it's here. I create proxy for coroutine A, proxy for coroutine B, and then I run that proxy and I supply through that lambda, I supply coroutine A that accepts proxy for coroutine B, and then one other task for this when all is proxy B runs coroutine B, which accepts proxy for A. And that's how it goes. So they, in the code for coroutine A, I have that proxy, which is exposed itself as IEnumerable. And before I start the progress of coroutine A, I can just loop here, basically doing nothing, just showing that little throw block here. Like, again, let me run it. Here. And then B does the same thing here. Waiting for something to happen, like coroutine A is waiting for something to happen in coroutine B. And the same thing is happening in coroutine B. When it reaches step number 40, it just goes through the proxy we created for coroutine A and waits till it's at step 40. And that's how it goes. It's a made up example, really. Doesn't do anything useful, but it shows you like, sorry, go on. Are you still with me?
Yeah, we're still. We love the ASCII art. We're just excited by it.
It's probably everything that I've done here could be replicated with some powerful established frameworks like reactive extensions, for example. Pretty sure. I'm just not as good with reactive. And there is one other thing is called TPL data flow, which is more like actors framework, like akka frameworks. It can be done there, but what I like about this is it's just linear execution flow. Like there are some statements like for, but it's still for. I don't have to deal with all that fluent multi-level syntax, which is I'm getting always lost with it. It's just like a callback hell for me. So that's what I like about it. But you can add any kind of timing, precise timing to that, and it gives you that specific time-bound workflow of these two coroutines being executed by now concurrently, or even I would say in parallel, because it's still the same UI thread, but we can't predict anymore, unlike with IEnumerable, we can't predict anymore which step goes after what, because we have delays, we have those specific synchronization points. So yeah, that's what it is for that simple example. I can run it again. That's basically the timeline. Why do I need that? It all feels a bit of over-engineered. Well, I have that little side project, which I call Dev Comrade. I started to collect sort of little utilities that I was always missing in Windows. It's that's what it is. There is a link in the repo as well. It started with spacing text. I wanted something that gives me pasting on format text unconditionally where I want it, when I want it, on my terms. I don't want to remember all those shortcuts like Control-Shift-V and it only works in Chrome. Or many people like go to open Notepad just to paste something here. Like even more dangerous stuff. Like I can often I'm bad at remembering things, so I need to go to find how I delete stuff in Unix, like in Linux. I want to delete all folders. So I go here, I select this thing, I go back to my terminal, and I really need to be very careful now. So let me do some temp folder. Go to that temp folder. And I kind of want to paste.
Do it in WSL. We want to see it.
I want to paste that, and I'm just see, and I pasted it, and I think I'm lucky because nothing got deleted.
You think?
I think so, yeah, because I've been in that trap for so many times, and usually you do Windows R and paste here, and then you just to make sure it's all good. There's nothing extra, and then you copy from here, and then you paste it here, and it goes like that. So still fine. I want something simple, so I want to be able to select a bunch of text from the screen, copy it to the clipboard, and then just be able to paste it. Oh, wow, ooh la la, not good. What if I could paste it as a single line of text? No worries. So I have that Windows plus F10 menu because I'm bad at remembering shortcuts, and there is paste a single line. Oh, let's see. Nothing happened. Okay, there's a shortcut for that. So I have a shortcut for that, which is what is it? It's win plus insert. Let me try one more time. No, nothing happened. Okay, I see. Yeah, that's the thing. If I launch it through mouse, the focus is already in my application. So if I launch it through Windows plus F10, the focus is in the terminal, and then I can paste. So yeah, that makes sense. I'm a command line guy. I don't use mouse too much. Well, anyway, Windows F10 works. Windows plus insert works. Let me do one more time. It works. And no matter how much text I copied, I should be able to paste it as a single line, and then I can have a chance to edit it and remove the crap that I don't need to. I wanted a way to test this feature in my application, so I'm going to load that side project of mine, and I wanted something that actually tests that workflow, because the workflow is completely asynchronous. It's simulated input. I feed it character by character to the current window. I check for many other things, like if all keys are depressed and the focus is still in there, and it can happen. User can switch away from your window, so it's asynchronous, and I need to be able to test it. So I've come up with that idea of using these coroutines, asynchronous coroutines, as two independent kind of components of single test. They both run on each on its own Windows Forms thread, because that's what happens in the real life. You are in one application and you paste from another one from this little taskbar application. So one coroutine, which represents the main window when I'm going to be pasting, runs on one UI thread. Another one here on one UI thread, like that's where it is here. Foreground apartment, I call it. Another one runs on the background apartment. And now they are truly running parallel. So they are not cooperative in any sense, but they do need to synchronize. So let's have a look upon the foreground one. It's a very basic thing. It creates a little form with a text box inside. And there is a bunch of, I don't use any for loops. I don't use any fancy execution control statements, but I just want one step at a time, one action, and then I want to synchronize with another one, background one. So I create the form, and then I kind of send a signal to the other coroutine that I'm ready here. So because it's return yield and we are synchronous, at that point execution gets suspended, and I'm not going to do anything. It's just like I asynchronously wait for what's happened. So what's happening in the background routine. And at the background routine here, I initially also I yield like a signal, like send a message that the background is ready. It's ready straight away because the background does nothing fancy. But then I await for the next iteration from my foreground routine. And when I get it, I want to make sure that it's ready. That's a message that the coroutine is ready. So that's a ready message. So at that point, you know what? Actually, let me run it, and then I'll continue. So we go to Test Explorer, and we have that keyboard input test, which I'm going to run. And I'm pretty sure it will just flick right away. Let's see. Oh, no. It doesn't flick right away. So it doesn't flick right away because when I was preparing for this demo, I think I've put a delay to my coroutine proxy that I talked about before. So it's still here. Test Explorer, run. Yeah, without any delays, it just clicks away. So it does make sense for me to put some delay here for illustration purpose. Going back to that test, the background routine, which I have here, waits for foreground to be ready. And then what it does, it waits asynchronously again for all keyboard keys to be released. And then it starts feeding some text. The text that I currently is in clipboard, and I want to paste it in that window. Going back to the foreground routine. So it sends a message to background that it's ready. Hold on a second. Yeah. And then it waits for the message from the background routine that the text has been sent here. And it does one more thing to make sure the UI queue is empty. And then it basically fetches the text from the text box and synchronously sends it back to that background routine. So that's how we kind of synchronize, because we need to make, if it was like 20 years ago, I would probably be using 2 threads with some manual reset events or something like that, like blocking constructs, like just block here until something happens there. In this workflow, everything is asynchronous. There is no blocking of any kind. It just like executes concurrently until some point in the timeline when I need to synchronize. So
very cool. Very cool. We might pause and throw open to questions if that's all right.
Yeah, sure. Yeah.
At this point.
Sorry, it's I'm rambling right now. It's like first talk in 15 years that I'm given, so bear with me.
No problem at all. So questions that have come through. Oh, geez, I'm going to have to scroll back through the chat now. Is anybody else getting a weird stutter in the video? No, that's not the question. Where are we? Where are we? James? Oh, there we go. What about link to async enumerables?
Oh, yeah, that's a good question. I think you can do that. So if you go back to, let me download that Coroutine project, which is in my kind of blog post format repo. And I have that demo where, one was on hold until something happens in another one. I think you can just, I haven't tried that, but I can try. Let's do that on Coroutine D. Like that's probably gonna be easy.
Let's just break it all right now in front of everyone.
No guarantee it will work as expected, but let me do something like that. So I'm gonna just comment this one. Yeah, the bunch of these lines I'm gonna comment. Come on. Right. So now instead of doing that await for each loop, let me try to do just some link. So I'm gonna be doing coroutine A, like let's see, take 40, yeah, take 40, and then last async. So as I said, no promises, but we're gonna give it a try. So
dun, dun, dun.
Certainly you can do link. It just I'm not sure how it's done behind the scene.
Oh, baby, there we go.
Yeah, it is working. Good, excellent.
Nice.
See? I didn't expect that, but it's in there. So yeah, you can. Some people used to compare this to reactive extensions, because in reactive extensions you can also do all kind of fancy stuff with link on IAbsorbable, and that's like an alternative to it. And the language support is in there, which is really good. So as I said, I used to to be lost in those trees of fluent syntax. And here you just have your typical asynchronous, typical linear, sort of pseudo linear workflow, which is good. So yeah, that's what it is.
The clowns in the Twitch stream are giving me a hard time because every time James puts a question up, I disappear, and they're loving it.
I guess that's what it is. Any more questions? Like anything? Like anyone is
Francis, you got it coming to you, mate. Later, find where you live.
It's like what's the real life user? It's just I'm only so far using it for this one, for that sort of manual coded UI testing. You can come up with a better use cases for this. It's pretty new to me either, so I guess there is a lot of opportunities, but it's a bit niche, I would say. So most people would probably pick reactive extensions.
It doesn't look like there's any more genuine questions coming through at the moment.
Well, then check out my tool. It's free and open source, and you might just like it. So the link is in the
likes
repo.
Your menus, by the way. He wanted to compliment you on that. So Francis said, where is it? I lost where the comment was, but yeah, don't take it the wrong way. But he said he likes your menus.
And people are very impressed with your live coding as well, which I was impressed with.
Well, thank you very much. I apologize for rambling and for being a bit nervous, but
it's all good. It's all good. We love it when someone has a go and steps up and speaks. So thanks, Andrew.
No worries.
Yeah. So
it's all in the repo. Check it out. Yeah, and maybe it makes sense.
We'll post it into the Twitch stream as well. James, have we got questions for the giveaways?
Yeah, we've got a couple of questions. So yeah, thank you very much, David, for your talk as well. I should have said that earlier. I've been waiting the whole time to say it, so I enjoyed that very much.
Yeah, it's a bit more down to earth. David's talk was up in the sky. This one is more like down to earth guy. So
I think both very talks. Right. So questions. So I've got an easy one first. So this one's more of a speed race. The second one's more of a knowledge one. So the first one is, can generators change the existing code? First one wins it.
Waiting for it. We'll watch it.
All right, shut poster.
Shut poster.
I think shut poster wins it with the actual correct answer, which is no.
And for having the best tag as well for 111888822. It's very unique.
Very good. Well, send me a message on Meetup with your email address, and I'll send you through the code. And I
have no idea how to identify it was actually you, so anyone can reply and say they were shut poster.
Shh, Richard. Shh.
Oh, sorry.
We'll give you our keys, and we'll do something clever. No, just to be honest, please. I'll reply. I'll write quickly. Yes, and the other question though, which is going to be a harder one, is how do you sync up the coroutines to like the way Andrew did it? Just what were the components used to sync?
To answer.
No,
you're not allowed to answer. You can't.
Is it? Do I? Oh, sorry.
No.
Still confused.
You deserve a license already, but
do I win a license?
All right. So, what was the name of the type of class or the type of thing that Andrew used so that he could synchronize up the two different coroutines? I think they stopped at like 40 or whatever partway through, and then waited for the second one. It was in the second diagram. If people have got the Git repo. Oh, there you go.
Oh, no, you don't get it. Sorry, you already got one. Someone else.
Oh no.
Oh, Dimitri.
Yeah, that's a good one.
I didn't say the rules that it was only usually one license per person. But shut posters must have been listening well. because that's the answer I was looking for. Ooh. What do you think? Have you got any backup questions, Richard?
Wait, was I meant to be paying attention?
We're definitely paying attention.
I was watching the stream. No, that's not true. Dimitri's close enough, I think.
Yeah. All right. We'll go with Dimitri then. We got implemented with the channel. All right. So send me his answer. Thank you, Richard, for that the solution to this problem.
That was the first talk. Yeah, good.
All right. So Dimitri as well. Send me through your email via Meetup, and I'll send you.
Or just ping the channel over the DM, and we'll pick it up from that.
All right, do that too. All right, so that's a giveaway. The only other thing is, if anyone's interested in giving a talk, following on from these gentlemen today who've done a very good job, then just ping one of us, and we'll talk about it. Because we're as always looking for speakers for the talks, and even if it's your first time, come on down. Everyone's friendly. Don't rib you too much, really. As you can see, you can rib each other actually, and Richard. All right, so thank you very much. Yeah, to both our speakers, and for coming along and listening tonight. And we'll put it on YouTube as usual afterwards. Yeah, Richard.
Yes. Sorry, I meant to say something else at this point. No. Okay. So again, David and Andrew, thank you very much. Everyone who's joined and stayed for the stream, stay safe, COVID safe. Don't hug anyone. Don't go kissing strangers. Don't go licking telegraph poles. You've been warned. That's it. We are done for the night. Go say hi to your family. We'll catch you in a month.
See you later, everyone.
Thank you very much. Thank you, everyone.
We out. Mic drop.